Okay, so we're continuing on in our second unit. We're going to take advantage of some of our skills that we learned in the first unit and we reviewed last time. We're going to do something a little bit new. Again, as I go through this class, I assume the things that we are doing you haven't seen before. So if you have seen it before, that's even better. Okay, so what we're going to talk about is what's called a system of linear equations. So we see here something familiar to us, the idea of a linear equation. Okay, we graphed those for the last couple sections before our test and after our test. So we're familiar with that concept. So now the idea of what is a system of linear equations. So if you look down the page here, we'll come back to that definition. Example 1, it shows you an example of a system. Okay, this system right here has two equations. Okay, so in general, any system is two or more equations, but we're just going to deal with systems of two equations in this class right here. So what does it mean when I have a system and maybe I'm asked to solve a system? What am I doing? What is the result going to be? And so before we talk about solving, I want to just kind of highlight the idea of what does it mean for something to be a solution? What is a solution? What does it look like? So going back right above example 1, it says an ordered pair that satisfies all the equations. An ordered pair that satisfies all the equations of a system at the same time is called a solution. Now, the reason it says all of the equations is because when you get to college algebra, we're going to talk about solving systems of 3 equations with 3 variables. Okay? Once you can do 2, you'll be able to do 3. It's not a big deal. But a solution in any event has to satisfy all the equations. So what we're going to do for these first 3 problems, I've got an example and you've got 2 examples, is we're just gonna kind of drill home this idea of what a solution is, because it's important to understand. And then we're going to go, we're going to develop a visual of what does a solution represent. So here we go. My first example says this. We're going to determine whether the given ordered pair is a solution to the given system. So again, just to remind you, if it's a solution, it satisfies both equations. So here we go, 4 and 2. So the first equation is x plus y equals 6. I'm just going to rewrite it over here so I have a little space to work. So when I go to substitute, my ordered pair is 4 and 2. So a point of review, what does the 4 represent? X. It's always x then y. That never changes. So the x is 4. So I'm going to put 4 in right here for the x. I'm going to put 2 right here for y. And then we're going to ask ourselves this question. And if you need to use a calculator, verify, is this true? Is 4 plus 2 6? Okay, so far so good. It satisfies the first one. I'm going to put a check mark. But before you can say that this is a solution to the system, it has to satisfy both. Okay, not just one. So let's look at the second one. The second equation is 4x minus y is equal to 14. So I'm going to take the 4 and the 2, the x and the y. So the 4 for x, 4 times 4 is 16. Can I just write that down? Does everyone see where I got that 16 from? I don't want to lose anybody, but just saving a little room on my page. Okay. All right, so 4 times 4 is 16 minus the y value, which is 2. Is equal to 14. Again, is 16 minus 2 14? Is that a true statement? Yes. Okay. So does the point 4, 2, does it satisfy both equations? Yes. So yes, it is a solution. A solution satisfies both systems, or excuse me, both equations of the system. So if you have a question about that, okay, I'm just going to remind everybody we're coming out of the first test. I've told everybody to make changes. So just remember, questions are a good thing when you have them. Ask me questions. I love questions. I get to talk. I love talking. Okay, and it means you're learning. Okay, so ask questions when you have them. I don't know you have a question unless you tell me. I can't read minds. So regardless, exercise 1 right below. Do the same thing. Is -1, 7, is that point a solution to that system? I'm going to give you about 90 seconds to make a determination. All right, let's see how you did. Let's see what the answer is. So the top equation is 3x plus 2y equals 11. So I'm going to plug in x is -1 and y is 7. So if x is -1, 3 times -1 is -3. If y is 7, 2 times y is 14. Is -3 plus 14 equal to 11? Is that true or not? Yep, true. Okay, so we'll go on to the second one. By the way, if the first one is not true, okay, then you're done. Because since it has to satisfy both, if it doesn't satisfy the first one, it's not a solution. Okay, so just don't make more work for yourself if it's not needed. So then the second equation is x plus 5y is equal to 36. So the x is -1. 5 times y is 5 times 7, or 35. Is -1 plus 35, is that equal to 36? No, it's not. What is it equal to? 34. So that one's not right. And so because it doesn't satisfy both, my answer is no, it is not a solution. And like I said, if we had answered no to the first one, then I wouldn't have even had to try the second one. All right, one more just to kind of nail home this idea of what a solution is. Go ahead and do exercise 2, same thing. Is -4, 2 a solution to that system right there? All right, so let's do the arithmetic on this and see if we're going to answer yes, it's a solution, or no, it's not a solution. So 2x plus y is equal to -6. That's the first equation. We're going to plug in the x value -4, the y value 2. So 2 times my x value is 2 times -4, that is -8. And then plus the y value is 2, and -8 plus 2 is indeed -6. So we are good right there for the first one. Then the second equation is x plus 3y equals 2. So when I plug in the x value of -4, I just plug it in right there. Then the y value is 2, so 3 times 2 is 6. -4 plus 6 is equal to 2. So yes. So hopefully your conclusion was yes, it is a solution. Is everyone tracking what the difference between a solution and a not? Has to satisfy both equations, okay, not just one. Okay, can I move on? Are we okay? All right, so now what I want to do is there's going to be 3 ways that we learn how to solve or come up with the solution to a system. And the first way is helpful because it tells us what a solution is. It's going to show it to us. So this also gives us a chance to practice a skill that we've done in a couple of previous sections. So what we're going to do first is we are going to solve a system by graphing. We are going to learn how to come up with the solution. That's what solving is. We're going to learn how to come up with the solution by graphing. So here's the system. The first equation is x plus y equals 5. The second equation is 2x minus y is equal to 4. So I'm going to just refresh your memory about graphing, and then on the first equation, then I'm going to give you a moment for the second equation. So just going to draw a little arrow. I'm going to write this first equation over here where there's a little room to manipulate it. I like to solve using the slope-intercept form so I can find the slope and the y-intercept. Okay, I think in general, that's usually the quickest way to graph. If you prefer the other way of graphing, that's totally fine. It's not going to be wrong. But if I'm going to solve this for y, what's the first thing that I have to do here? Got to move the x. How am I going to move that x? Subtracting in this case, so subtract the x. Remember, it's always the same two steps. You move the x term, and then you divide by whatever's in front of the y. So then I end up with y is equal to negative x plus 5. It just so happens there's nothing to divide by on this one, so I'm done. What's the slope of this line right here? Yep, it's whatever's in front of the x, which is a -1, which I like what you did. You wrote it -1/1 so that I have a fraction. Again, I'm just trying to refresh your memory on things to keep everything right in front of us. Slope is always the y on top. Okay, where the line is moving in the y direction on top over the x direction. That never changes. What's the y-intercept of this line? 5. I'm going to write it as 0, 5, but 5 is perfectly wonderful. And so let's go ahead and graph that. So the y-intercept is 5, so I'm going to go up 5 units. I'm going to make a dot right there. Lovely. My slope is -1/1, so that is -1 in the y direction, and then +1 in the x direction. So that's 1 down, 1 right. Make a dot. 1 down, 1 right, 1 down, 1 right, 1 down. Having a great time going down the steps. 1 down, 1 right. I'm going to stop there. Take my straight edge. I'm going to connect those dots. There's my first line. So here's what I would like you to do. I'm going to give you about 60 seconds to do this. The second line is 2x minus y is 4. Go ahead and graph that, and then you can go ahead and stop, and then we're going to talk about what is the solution and where do I find it. Step number 1, how do I move the x term on this equation? Yes, thank you very much for that definitive statement. Love it. I'm going to subtract the 2x. Now, don't forget this negative in front of the y. That's important. You can't just leave it off. I saw a little bit of that on the test. Then I have -2x plus 4. What do I have to divide by to get the y by itself? A -1. And please don't forget that division is distributive just like multiplication is. So that -1 gets divided into both terms that are on top of it. So -2x divided by -1, a negative divided by negative is +2x. +4 divided by -1 is -4. And that means my slope is what? Perfect, love it, 2/1, whatever the number in front of the x is the slope, and the y-intercept is perfection. So I'm going to start with the y-intercept, 0, -4. My slope being 2/1 means I'm going to go +2 in the y direction, +1 in the x. So that is 2 up, 1 right. 2 up, 1 right, 2 up, 1 right, 2 up, 1 right. One more time, 2 up, 1 right. There's all my points. I'm going to connect those dots. Okay, so the reason I have us do a couple of these problems graphing is because I want us to be able to see physically what the solution means. If you had to point out where you think the solution is to that system, where would you point? Yeah, where they intersect. Yeah, where they cross over. That's why the solution is the point that satisfies both. It's the intersection point of those. And so on the test, here's my promise to you. on the test, you're going to have a problem that you have to solve by graphing, okay, for sure. And so now this is a key point. If you have a question, let's read the solution. What is the x coordinate of the solution? Okay, I'm go over 3. So the x coordinate of the solution is 3. What's the y coordinate of the solution? Up 2. So that everybody knows it's a solution and not an interval. We write our solutions as sets. So I'm going to put some braces around it. Otherwise, it might be confused with an interval. And I'm just going to make note for this first one for your notes that intersection point, that is the solution to the problem. Anybody got a question before I flip the page? I don't want to leave anybody behind. All right, flip the page. At the top of the next page, then you've got a problem. You're going to solve this by graphing. Okay, so go ahead and I'm going to give you 2 or 3 minutes. Exercise 3. Go ahead and solve both of those equations for y and graph them and come up with what you think the solution is. So that's still going to be the solution. You just All right, I'm going to get started. Check your work with mine, ask questions when they come up. Let's make sure we leave here fairly clear on graphing. So 2x plus y is -5. That's the first equation. There is one step to solve that for y. And what is that one step? Yeah, I'm going to subtract that 2x. Thank you very much. And so y is equal to -2x minus 5. There's a positive 1 in front of the y, so there's nothing to divide by there. So that means my slope is -2, which is -2 over 1. My y-intercept is 0, -5. There's my information that I'm going to use to graph. So I go down 5. My slope being -2 over 1 means -2 in the y direction, so down 2. Positive 1 in the x direction, so right 1. So down 2, right 1, down 2, right 1. I like a couple more points. So instead of going down and right, I'm going to go up and left. So here we go, up and back, and then up and back one more time. So there are my points. I'm going to connect the dots, and that's the first line graphed. There it is. The second line, I'm going to solve that for y as well. So this one, I'm going to add x. I'm doing the opposite. And I have 3y is equal to x plus 6. This time I do have the second step to do to solve this one. What's the second step? Divide by 3. Well said. Appreciate it. And I'm going to distribute. And I notice that the number in front of the x presently is a 1, even though it's not written. So now I've got 1 divided by 3. So that's 1 divided by 3x. And then 6 divided by 3 is 2. So my slope is 1 over 3. My y-intercept is 0, 2. So I will go up 0, 2. There's my y-intercept. The slope is 1 over 3. That's positive 1 in the y, positive 3 in the x. So positive 1 in the y, positive 3 in the x. 1, 3. Let's go one more time. 1, 3. And when I connect the dots, looks like it's going to line up really nice here. Whee! What would you declare for me is the solution to this system right here? Yep, negative 3 in the x direction, and then positive 1 in the y direction. And then you put braces around it, so that's not confused with an interval because the notation looks similar. That is a solution set. One of the hardest things for students sometimes in my classes is being able to read what the intersection is. Is anyone having a problem determining that that's negative 3 in the x direction and then 1 in the y direction? We doing okay with that? Okay, so we're taking a skill we already have talked about in a couple different sections, and we're recycling it to solve systems. Now, the nice thing about graphing is that we got a picture and we're very visual people. We can see what a solution is. The bad thing about graphing is it really only works good for us if the intersection happens on one of the grid points where I can read the solution easily. Graphing doesn't work great for fraction or decimal answers, or when I slope intercept form's not easy. So there are two algebraic ways to solve that I'm going to show you. I'm going to try to tell you when I recommend doing each of them. But bottom line is on the test, you have to do one the first way. You have to do one the second way. And then on the other two problems I give, you can do any way you want. I don't care. So the first way we're going to do is we're going to solve a system by what's called the substitution method. Okay. Students every semester say, Perkster, when do I want to use the substitution method? Like how do I know which to use? And again, they both work all the time, but the substitution's a little more limited and when it works well. So what I recommend is you use this thing called the substitution. You use it when one variable is very easy to solve for. And by easy, I kind of just mean one step, okay, where there's not anything to divide by. Okay, substitution is best used when variable is easy to solve for. Like if you're solving for something and you end up with fractions, that's not a good time to use substitution. Okay, we want to avoid substitution and any extra work. My point here is to try to get this to be as easy as possible, not a headache at all. So my first example, notice in this, my top equation is 2x minus y is 6. But the second equation, I've already done the work for us. Okay, it's x equals y plus 2. So I've minimized the work on this one just because I'm showing you what substitution is. This second equation says x is an equal sign, remember, means the same thing as. X is the same thing as y plus 2. So here's what I'm going to do. I'm going to take the y plus 2, okay, and I'm going to plug it in. I'm going to substitute it for x in the other equation. Okay. I'm going to take that x is the same thing as y plus 2, and I'm going to take that y plus 2 and plug it in for x in the other equation. Now, usually the most challenging thing here is just making sure you substitute properly so that you get the right value. So I'm just going to go back to what I told you last class when we were talking about functions. When I take this 2x minus y is 6 and I rewrite it, instead of writing the x, I'm going to write some parentheses. Okay, 2 times x, but x is the thing I'm substituting for, minus y. equals 6. And now instead of x, this second equation says x is the same thing as y plus 2. So I'm going to put y plus 2 right here. And now I've got an equation with one variable. We learned how to solve this, or we reminded ourselves how to solve this first day of class. So I'm going to distribute. I'm going to collect my like terms. I'm going to come up with my value. So here we go. When I distribute 2 times y plus 2, I've got 2y. 2 times 2 is 4. Minus y equals 6. 2y minus y is 1y plus 4 equals 6. And then the very last thing I'm going to do is I'm going to subtract 4 from both sides, and I come up with my y value is 6 minus 4, or 2. Now, does anyone have a thought or a suggestion of, I've got the y value, what am I going to do to come up with the x value? Yeah, I'm going to plug into, you can actually plug into either equation, absolutely does not matter. I'm only going to use the bottom equation here because it's already solved. It's more convenient. Okay, so I'm lazy when I can be. So I'm going to take this y equals 2 and I'm going to put it into this equation. So this equation says x is equal to y plus 2. So that means x is equal to 2 plus 2. So x is 4. So my point, my solution is the x value 4, the y value 2. I'm going to put that in parentheses because it's a point, but then so everyone reading my answer knows that that's a solution set and not an interval. I'm going to put braces around it. And I'm done. That's substitution. You take one equation, you plug it into the other. Substitution's best used when one of the equations can be solved quickly for a variable. So exercise 4 right below. Again, I've already done the work. I've already solved one of the equations. So all you have to do in exercise 4 is take the 2 minus y and substitute it into the other equation. So do that, come up with your value, and let's see how you do. And if you have a question, raise your hand. I'll come to you. Happy to do it. All right, so let's see how you did on this substitution. So the bottom equation says x is the same thing as 2 minus y. So that means wherever you see an x in the other equation, you're going to substitute 2 minus y. So visually, I'm going to take this 2 minus y. I'm going to plug it in for x right there. So let's do the algebra on that. That top equation says 5x minus 3y is negative 6. So that's 5 times whatever I'm plugging in minus 3y is equal to negative 6. What I'm plugging in, x is the same thing as 2 minus y. So I put the 2 minus y right there. So talk me through, just to help me out, what do I get when I distribute the 5 times the 2 minus y? 10 minus 5y. Perfect. Love it. And then minus 3y is equal to negative 6. Let's collect those like terms. What does my calculator tell me when I have negative 5y and negative 3y? That's 10 minus 8y. Yes. We're solving. So all of my y's are already on the same side. So I got to move the 10. How do I move the 10 to the other side? Subtract, well said. Did I do arithmetic wrong somewhere? Oh, yeah, no, I have not. I'm doing perfect. Just not thinking clearly. Okay, now I have negative 8y is equal to negative 6 and negative 10 is negative 16. And then I divide. And my y value is 2. And again, you have liberty here. You can take that y value of 2. You can plug it into either of the original equations. It absolutely does not matter. If you don't believe me, go ahead and use the other one that I use, and you'll end up with the same x value. I'm just going to use the equation that's already solved because it's a little more convenient. So that's x is 2 minus that y value of 2. So the x value is 0. So that means my ordered pair is the x value 0, the y value 2. Since it's a solution set, I put braces around it. And I'm done. I've got one more substitution problem for you all to do, but before we do that, any questions? We doing okay? I'm going to have you do a problem on the test by substitution. I promise. Okay, so expect it. Put an asterisk by it. I'm telling you all the stuff on the test. All right, so exercise 5, top of the next page. Now notice on exercise 5, I haven't done the work for us, okay? I have not solved one of the equations already because I just want to make sure you understand what I mean by picking the variable that is quickest and cleanest to solve for. So in that system, what is the variable that is going to be the quickest one to solve for? It's in the equation 4x plus y equals 5. Which variable is it? The y, because there's nothing to divide by. Okay, so this is what you want to solve for. I'm going to put a little arrow. So I'm going to give you 20 seconds. I want you to solve that top equation for y, and then stop, and we'll compare notes. What is the step to solve that top equation for y? Yep, awesome. Subtract 4x. Well said, and it's perfect, and it's one step, and I'm done. So I've got 4x plus 5, or excuse me, negative 4x plus 5, or if you've written it 5 minus 4x, that's equivalent. Doesn't matter. That's what I mean by pick the thing that's the least work to solve for, okay? Anything that's one step. If you end up with fractions, don't use substitution, okay? That's just a pain. So now what I want you to do is finish this problem out. This says y is the same thing as negative 4x plus 5. So in the other equation, wherever you see a y, you're going to put negative 4x plus 5. Right, so I'm gonna take the negative 4x plus 5. I'm gonna plug it in for y in the second equation. So I drew a little arrow there to show you pictorially what I'm doing. So I've got 2x minus 3 times my new y value, we'll plug that in a minute, is equal to 13. And what I'm plugging in is the negative 4x plus 5. At this point, I'm hoping this looks super familiar. This was Unit A. This was the very first section, first day we met each other, solving equations. So this is 2x. Negative 3 times negative 4 is plus 12x. Negative 3 times positive 5 is negative 15, is equal to 13. 2x plus 12x is equal to 14x. Minus 15 is equal to 13. I'm going to add the 15 to both sides. And I have 14x is equal to 28. And last but not least, I divide and I get my x value on this one. The x value is 2. Which equation do you want me to plug the 2 back into? The top one or the bottom one? I heard top first. So if you wanted the bottom one, do that and we'll compare notes. We should get the exact same thing. So because I heard the top one first, the top equation is 4x plus y is equal to 5. The x value is 2. So 4 times 2 is 8 plus y is equal to 5. And when I subtract the 8, whatever you did, the y value should be negative 3. That makes my ordered pair. The x value is 2. The y value is negative 3. I put some braces around it because it's a solution set. And there we go. We're done with the problem. Did anyone plug 2 into the bottom equation? Okay, well, if you did, you would have gotten y is negative 3. Okay, it will be the same point. So that is substitution. Substitution works nice if the system is set up right, where you got something that's quick and clean to solve for, but that's not the majority of the things we encounter. So we want something that is going to give us the smoothest way to come up with an answer. Just as an aside, a timeout, the main reason I even bother to tell you about substitution in this class is because when you get to college algebra, when we talk about solving nonlinear systems. So you'll do a problem in college algebra where you're given a system and one of the graphs is a circle and the other is a parabola. The easier way to solve that is by substitution. Okay, so it does have value for other things. For linear systems, it's not really always the best thing to do. What usually is the best thing to do is solving the system by what's called the elimination method. So for my first example, I've set this up just to show you what I mean by elimination. Okay, so this first example is just going to be one step. When I look at my equations, I've got 2x plus 3y is negative 6. I've got 4x minus 3y is equal to 6. What do I notice happens on the left side? What do I notice happens here if I was just going to go ahead and add these equations together? What cancels out? I'm not worried about the numbers. I'm worried about the left side of this. What happens on the left side of this if I just add these together? The 3y and the negative 3y cancel. That's what elimination means. I want to set my problem up so that when I add the equations together, one of the variables cancels out. So let's do that. Let's just add these up now. So when I do that, 2x plus 4x is 6x. Positive 3y minus 3y, those things cancel. And then, yes, just as was mentioned to me, this is just by chance. Negative 6 plus 6 cancels, and that becomes 0 on the other side. 0 is a number, so I need to have something on the right side of this equation. Now I'll divide both sides by 6. And now x is, when I take 0 of something and divide it into 6 parts, it's 0. So I've already got half my answer by eliminating, and it just happens by adding the two equations together. Now I'm going to take the x as 0. I'm going to plug it into one of the equations. It doesn't matter which one. Do we want to do it in the top one or the bottom one? Okay, top. Okay, nice and bold and loud. I love it. So the top equation is 2x plus 3y is equal to negative 6. The X value is 0. So when I put that X value in, what's 2 times 0? 0. So that just becomes the equation 3y equals 6. So I divide both sides by 3 and I get y is equal to 2. And so that's my ordered pair answer. My answer to this is the X value 0, the Y value 2, and I'm going to put it in some braces and we are done. Yes, arithmetic. So that's a -6. I apologize. I was just so excited to be solving the system. So partial credit for the Perkster. -6 divided by 3 is -2. So there we go, -2. Much better. All right, so hopefully we can do the arithmetic, or I can do the arithmetic better on exercise 6, but I'm going to give you a head start. So exercise 6 is also set up that you don't have to do anything but add the equations together to eliminate. So go ahead and come up with what your solution to that system is, please. All right, so let's see how you did. I'm just going to add these two equations together straight away. So here goes. So I've got 8x plus 5x, that is 13x. The -2y plus 2y is eliminated. That's the whole purpose of the elimination step. 5 minus 18 is -13. And when I divide both sides of that by 13, I get my x value is -1. Top equation or bottom equation to find out the y value? Okay, top is what I heard first. So 8 times the x value is 8 times -1 is -8. Minus 2y is equal to 5. I'll add 8 to both sides. And I get -2y is equal to 5 plus 8, or 13. And when I divide by -2, I get y is equal to -13/2, or -6.5 if you prefer a decimal there. That's okay. Remember, the strength in not graphing to solve is that we can identify when we have fractional answers. So that's a perfectly wonderful answer. And so we've got -1 and -13/2. I'm going to put some braces around it, and I'm done with that problem. Okay, we got one more on this front page. So if you've got a question about elimination so far, that'd be great to bring up. So exercise 7, here's what we're going to do. We're going to do this in 2 parts. So I'm trying to give you a look at every different situation that you're going to encounter as you solve these. So I've got the top equation of -2x plus 5y is 22. No big deal there. What's the big deal about the second equation? Fractions. Oh no, screeching halt. So what we're going to do is what we did in the first section we were together. I want to avoid the fractions. So what we're going to do here is we are going to clear the fractions, just like we have done in the past. So what am I going to multiply each of the 3 terms here by in order to clear the fractions? 4. 4 is the least common denominator. But remember, I shared with you a math secret, okay, because I share secrets with you when I have them. If you multiply by 8, if you multiply by any common denominator, it'll still work, okay? You're just going to get slightly different numbers, but your answer will be the same. But here's what I want you to do. I want you to multiply every one of those terms by 4, clear the fractions, and then stop. I just want to make sure we're all in the same place. So when I do this, the first term, I've got 4 times a half. What's half of 4? 2. So that first term's 2x plus. The second one, I've got 1/4 times 4. What do I get when I multiply 1/4 times 4? 1. So that's 1y, or just plain old y. And then equals, again, I just asked this, a half of 4 is again 2 on the other side. I'm going to rewrite the top equation right above it. So negative 2x plus 5y is equal to 22. Then that second equation now has no longer has fractions. It's another problem that is set up straight away to eliminate really quickly. So go ahead and do that. I'm going to give you about a minute to go ahead and finish that. Yeah. You can multiply. Each equation is an independent thing. So because I multiplied the bottom equation by 4, I do not have to multiply the top equation by 4. Okay, they are separate entities. Great question. But just to make sure we're clear, you do have to multiply every term of that equation by the same thing, not just half of it or the other half. Okay. All right, here goes. I'm going to add these up. So the x's, negative 2x plus 2x, those eliminate. Great. I've achieved my goal. 5y plus y is 6y. And then 22 plus 2 is 24. Divide both sides by 6, and I've already got the y value. The y value is equal to 4. And then I'm going to pick, this time I'm going to pick the top equation because I'm still avoiding those fractions. So the y value is 4. The top equation is negative 2x plus 5y is equal to 22. I'm going to pop the y value of 4 in there. So I've got negative 2x plus 5 times 4 is 20. I'm now going to go ahead and subtract the 20. And I've got negative 2x is 22 minus 20 is 2. And I divide. You can see each time we do these problems, we're pretty much doing the same thing. So hopefully you get some brain muscle memory as you're doing this. So my solution set is the point negative 1, 4. Yeah. If the, I don't understand the question. If the fraction, what do you mean if the fraction wasn't 1?
So,
yeah, if when we did that before, so the question is, let's say this fraction here is 3/2 instead of 1/2, what would I do? Well, what you would do is say 2 goes into 4 twice, and then you take that number 2 and you multiply by whatever the numerator is. Okay, so it's just multiplying fractions, and we're doing that by canceling. Sure. All right, flip the page. We're almost done. You're doing great. The last situation we have to deal with elimination is what happens if I haven't given you a problem that has 2 of the coefficients that cancel out right away. Okay, which is kind of the more common thing that you're going to see. So here's my example 5. This is my last example of the day, and it says this. My first equation is 5x minus 2y is 4. The second equation is 2x plus 3y is 13. Now here's the choice you have. First off, it doesn't matter which variable you choose to eliminate. Okay, so you can choose whatever you want. So I'm going to let you choose. What do we want to do? Do we want to eliminate the x's or the y's? Okay, I heard x's first, so that's what we're going to go with. So let's focus on the x's right here. I've got a 5x and I've got a 2x. What's the multiple that 5 and 2 have in common? 10. So here's my goal. I want to get a positive 10 in front of one of the x's and a negative 10 in front of the other. Okay, that way they'll eliminate. Does that make sense? That's just what we were doing before, but it was already set up. So with that suggestion in mind, what do you propose I multiply the top equation by? Okay, I heard -2. What is that going to give me in front of the x? A -10. So if you choose -2 for the top, what do you have to now choose for the bottom equation? +5. Okay, because that'll be +10. I'm going to call a timeout because I know people got questions. Okay, I've taught this class before. Somebody in here, first off, is thinking, hey, Perkster, what if I had multiplied by +2 in the top? Okay, so I'm covering up the negative. What if you did? If you multiply by a +2 in the top, what then do you have to do in the bottom? -5, so that they have opposite signs. A second question somebody has here. Hey, Perkster, what if I had wanted to eliminate the y's? I was already working the problem. Okay, well, let's look at the y's before we finish up. In my y's, I've got a -2 and I've got a 3. Here's the nice thing about the y's. They're already different signs, so you don't have to worry about that. What's the common multiple between 2 and 3? 6. So you would want one coefficient to be +6 and one to be -6. Okay, so that means you'd multiply the top by 3 to get -6 and the bottom by 2 to get +6. But that's not what we chose to do, and it absolutely does not matter what you pick. There's no wrong answer there. So here we go. I'm going to take these equations, I'm going to multiply them. So I'm going to write them over here on the side where I have a little more space to write. So -2 times 5x is -10x. -2 times -2y is +4y. And -2 times 4 is -8. The bottom equation, 5 times 2x is +10x. 5 times 3y is +15y. And 5 times 13 is going to be, I believe if I'm doing my multiplication right, which you have every right to doubt today, that's 65. And so now when I go to add those two things together, you notice the x's cancel just like I wanted. -10x plus 10x cancels. 4y and 15y is 19y. And then -8 and 65, that's 57. I'll divide. And your calculator is going to tell you the good news that 57 divided by 19 is 3. It absolutely does not matter at this point whether you take that y is 3 and plug it in the top equation or bottom. The only reason I'm going to pick the bottom equation here is I've just got space underneath it to do the work, so it looks a little neater. Okay, so I'm going to take the y equals 3. I'm going to plug it in the bottom equation. So I've got 2x plus 3 times the y value, so 3 times 3 is 9, is equal to 13. Subtract the 9, and I get 2x equals 4. Divide by 2, and I get the x value is 2. So my ordered pair, my point is x value 2, y value 3. It's a solution set, so I throw some braces around it. So here's what I would like you to do. I'm gonna just tell you what to do on the next one, so we're all doing the same thing. Exercise 8, let's eliminate the y's. Okay, just so that we're all doing the same thing. Exercise 8. Solve it by eliminating the y's. I'm going to give you 2 minutes to make as much progress on eliminating the y's and solving as you can. just to give everybody a nudge, I asked us to eliminate the y's. So considering I have a 3 in front of one y and a -7 in front of the other, what did you choose to multiply the top equation by? 7. That's going to give positive 21. And then what are you going to multiply the bottom equation by? 3. That gives -21. The reason they're both 7 and 3 are positive is because in the equation, there's a negative in front of the 7 already. They are already opposite signs, so I don't need to worry about that. All right, so I'm going to get started with the arithmetic. If you're working, keep working. Check your results with mine. So I'm going to multiply the top equation by 7. So 2x times 7 is 14x. 3y times 7 is 21y. And then 19 times 7, 9 times 7 is 63. Carry the 6. And so that's 133. And then the bottom equation, 3x times 3 is 9x. -7y times 3 is -21y, and -6 times 3 is -18. When you smush these two equations together, 14x and 9x is 23x. The 21y's cancel. 133 minus 18 is going to be 115. Is that right? And divide both sides by 23. And the good news is our calculator tells us that that is 5. Take the 5, pick your favorite equation, flip a coin if you want to. I'm going to use the bottom one again just because there's the white space beneath it that I can write in. So I've got 3 times x, so that's 3 times 5 or 15 minus 7y is equal to -6. Subtract the 15. Lots of equation solving here. Good times. -6, -15 is -21. And when I divide, I get y is equal to 3. So my ordered pair answer, the x value is 5, the y value is 3. Throw some braces around it, and we are done with the problem. All right, we're close to the finish line. Exercise 9, it's just the same thing. This time, eliminate the x's, okay, just to make sure we're covering all of our bases here. Eliminate the x's in exercise 9, please. So in case you didn't hear and you're interested, the question is, why are both the 7 and 3 positive? It's because our goal is to get the coefficients in front of the variable opposite signs. Okay. What's the sign in front of the 3 right now? What's the sign in front of the 7 right now? They're already opposite signs. So now 7 times 3 gives me positive 21. 3 times -7 gives me -21. Now they will eliminate. right, just to give everybody a nudge in the right direction, I asked us all to do this problem by eliminating the x's. Not that it matters, but just wanted us to do the same thing. So right now I've got a 3 in front of the top x, a 5 in front of the bottom x. So what do you propose I multiply the top equation by? Okay, -5. That's great. If you chose -5, that gives you a -15x. So what then do you have to do for the bottom equation? +3. They have to have the opposite signs. Now, if you chose to multiply the top equation by +5, then you would do -3 on the bottom equation. They have to have opposite signs once you're done multiplying. When I multiply the top equation by -5. Now remember, if you did +5 here, that is perfectly wonderful and legitimate. You just have your signs reversed of me, and that's totally fine. So the top equation is -15x, and then -20y equals +30. Because I multiplied the top equation by -5 and have a -15x, I have to multiply the bottom equation by +3, so I get +15x. Your goal in every instance is these two things have to have opposite signs so that when you add them, they cancel out. 3 times 3y is 9y, and then 3 times 1 is 3. When I add the two equations together, the 15x's cancel. -20 plus 9 is -11y. 30 plus 3 is 33. And when I divide by -11, I get my y value is -3. I'm going to pick the bottom equation again. If you used the top, we should have the same x value as a result. So I've got 5x, and then 3 times the y value. 3 times -3 is -9. Add 9 to both sides, and I get 5x equals 10. Divide, and I get that the x value is 2. So my ordered pair is the x value 2, the y value -3. That's my solution set. All right, we're almost done for the day. I'm going to walk us through the last two problems just for time's sake. Okay, it's more elimination, but these last two problems are two special results you might get, and I want you to be able to discern the difference. So move with me down to exercise 10. Exercise 10, we've got 2x minus y is 3 is the top equation. 6x minus 3y is 9 is the bottom equation. So if I want to eliminate the x's, okay, if I want to eliminate the x's, I only have to multiply the top equation by something. And what do I need to multiply that top equation by if I'm going to eliminate the x's? Close. -3. Has to have the opposite sign. So when I do that, the top equation becomes -3 times 2x is -6x. -3 times -y is +3y. And then -3 times 3 is -9. The bottom equation, I haven't done anything to, so it stays 6x minus 3y is equal to 9. I'm just giving you a moment to catch up in your writing, because the real important part to this problem is what follows. Okay, that is standard stuff, elimination. As you practice, you'll get used to doing that. So I wanted to eliminate the x's, so -6x plus 6x cancels, that's great. But then I noticed what accidentally happens to the y's. They cancel as well, so I have nothing left on the left part of the problem. I got 0. On the right side, -9 plus 9 is 0. Okay, so that's weird. I have no variables left. I have this statement 0 equals 0. So knowing what you know about arithmetic, is 0 equals 0? Is that a true statement or a false statement? True, 0 equals 0. That's true. So mathematically, what we call this is a dependent system. Now, I know that doesn't do much good for you about what's going on here. So what does it mean when you have a dependent system? Well, what it means is you have, if you're thinking about pictures and graphing, you have two of the same line. One line has just been drawn right on top of the other. And because you have two of the same line, that means they intersect at every point on the line. Kind of like a Ziploc bag. When you close the top, okay, it intersects everywhere. Okay, so that's every point on the line is the solution. And so the way that we write this, every point on the line is the solution. This is how you're going to put it into MyMathLab. It goes like this. It's the set. MyMathLab is going to give you this part. It's the set of x's and y's. It's the set of ordered pairs such that, and then this is the part that you're going to contribute when you notice you have a dependent system. Okay, it's the set of ordered pairs that satisfy this relationship: 2x minus y equals 3. I just used the top equation. It's the set of ordered pairs that satisfy this relationship. This is how you write that the intersection is every point on the line. So that's a little bit of a goofy result. And then one more. Yeah.
So for a question like that, where all you have to do is on the top, turns it by -3. You don't have to do nothing to the bottom.
Not on that one, because the bottom already has a coefficient of 6. So to get a common multiple, I only had to multiply this one by -3 to make opposites. Okay, sometimes that happens. Sometimes that happens even when it's not a dependent system. So that can happen other times. All right, so the bottom equation or bottom system, I've got x plus 3y is equal to 4. Negative 2x minus 6 is equal to 3. Again, I want to eliminate the x's. What do you suppose, or what do you propose to me I multiply the top equation by to eliminate the x's on this one? 2. And again, because the bottom equation is a -2, I don't have to multiply the bottom one by anything. I just created a couple of simple examples for these special situations so as not to take up too much time. So now you okay? You sure? Okay, so I'm going to multiply the top equation by 2. 2 times x is 2x. 2 times 3y is 6y. 2 times 4 is equal to 8. The bottom equation is -2x minus 6y is equal to 3. And once again, like the previous problem, I was eliminating the x's on purpose, so 2x minus 2x cancels. But once again, what happens to the y's? They cancel as well, so I have nothing on the left. But this time on the right, what do I have when I add the equations together? 8 plus 3 is 11. So we kind of get the opposite result. Is 0 equal to 11? Is that a true statement or a false statement? It's false. Mathematically, what we call this is an inconsistent system. And I know the word inconsistent doesn't do much for you. So again, if I think about what is going on my Cartesian plane with this, well, instead of having the same line, what I have here is I have parallel lines. And I don't know if you're familiar with the term parallel. So if you're not, parallel lines never intersect. They always stay the same distance apart, like train tracks, hopefully. Okay, so parallel lines never intersect. So when I solve my system, if I'm looking for where the two lines intersect, and I've got parallel lines that never intersect, then the solution is the empty set. There's no solution for that system right there.